Okay, so this mini lecture is on the difference between weight and mass. Weight and mass, often used interchangeably incorrectly, so we want to make sure we understand the difference between weight and mass. Now, fundamentally, mass can be thought of as the stuff. So the stuff an object is made out of. It doesn't change regardless of where I am in space. It's what I'm made out of, what my stuff is, what my molecules are, how massive they are. The stuff itself, okay? The weight is a little bit different. Weight is the force that gravity exerts on that stuff. So, this is my force of gravity. The force of gravity is equal to the weight. And we learned in the previous sort of catalog of forces that the force of gravity is equal to the object's mass times the acceleration due to gravity, which we called g, where g, remember, was the magnitude of that acceleration. So it doesn't have a sign. We represent that force with an arrow. The direction is defined as down. So we know that that force has a negative direction. The magnitude of that force is equal to mass times gravity. Now when we draw forces on our free body diagrams and we represent forces in a problem, we're going to represent the force of gravity as an arrow in that problem, and we're going to remember that it's mass times gravity. So the mass is the stuff. The force of gravity is the weight. They're equivalent names. Now, let's think about that in terms of a conceptual example. Let's say you have a mass of 20 kilograms on Earth. So the mass of the object is 20 kilograms. The weight of that object on Earth is equal to its mass times gravity, which is the force of gravity. Those are equivalent values. And so the weight of that object is equal to the mass, 20, times gravity, 9.8. It's equal to 19.6 newtons. So this is on Earth. Now what if I take that same mass to the moon? Well, has the mass itself changed? Has the stuff that that object is made out of changed? No. The mass is still 20 kilograms. It does not change. It's a representation of the physical item that we're dealing with. But what about the weight? Well, the weight is mass times the acceleration due to gravity of the planet that the object is on. So in this case, it's the gravity of the moon. That's the force of gravity of the moon on that object. Well, gravity on the moon is about 1/6 of the gravity on the Earth. And so the weight on the moon is lowered. It's less than the weight on Earth. So the weight on the moon is less than the weight on Earth because gravity on the moon is less than gravity on the Earth. So conceptually, I'm not going to worry too much about the numbers. Conceptually, the weight can change depending on the gravitational state that the object is experiencing. It's less on the moon. To lose weight, just go up to the moon. If you want to lose mass, you're kind of stuck exercising. So, weight is the force of gravity. Typically, that's on Earth, on all of our problems. The mass doesn't change. It's the stuff that we're made out of. All right. Good job.